Hello guys, so today I'm gonna show you how to create a Sudoku solver, which I already made. So let me show you. Okay, so this output is not properly um, it's not properly shown. You see, this font is not monospaced, but we will actually fix that in our solution. Okay, so let's start from the beginning. We will need a class. Let's call it Sudoku cell. And what that class we can make it public needs to have. So an x coordinate, we need it to have y coordinate. We want some sort of boolean, whether it's solved or not. And let me check if I remember correctly. Oh yeah, of course we need a number, which is also integer, which will go into that cell. And I'm using this, I'm overriding to string to basically just display something during debugging, and whenever you, I don't know, have a string like this. Let me see. Okay, so something's wrong. Okay. So whenever you have a string like this, for example, if you just put some Sudoku cell here or something else, the method to string will be automatically called. So what I wanna achieve by this is actually to just display the number if the cell is solved, or otherwise display this small x. Okay, so this is our basic, most important class to have. So in our solver I set up already some stuff we might need, like size and box size. As you know, the Sudoku has a box that is something like this, right? So its size is actually 3 by 3. Okay, and it's a square root of the actual size of the Sudoku. This will be our input string, and here we will use the input string to manipulate it, actually solve the Sudoku. Okay, as you can see, I already set up something like this. Let me run it. I use the match colors. Okay, so we got okay, you can see Sudoku Solver instruction, copy Sudoku line by line, then what you solve it, and then you input some Sudoku, blah 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 blah, and it should work. But for now there's nothing there. Okay, and I left this method here. This method is actually to just display it in a cool kind of box, and I will not go into detail how I did this, but we will do everything else. So first of all, I saw this method here is missing get row. So let's start off by doing those two. So the idea is to have methods like get row, get column, and get box, which will return all the boxes in the row, and all the boxes in the column, and all the boxes around the selected cell we are working with. And get markers is basically gonna get all the possibilities that can go into a single cell. And before all that, we will need to have this initialize cells method, in which we will actually convert our input to something that we can work with, which is two-dimensional array of Sudoku cells. So first, let's define private read-only Sudoku cell. Okay, it's in models namespace, and let's call it cells. Simple as that. Okay, so and yeah, don't make this. Actually, let's just leave it as static. Why not? Private read-only static string Sudoku cells. Okay. Now that we got the input, let's create a private static void initialize cells, in which we will do the double loop. First one will be by I, and the second one by J, both by size, and we wanna initialize these Sudoku cells here. Okay. Let me also see. So where do we initialize this? Do we even initialize this anywhere? I guess not. Okay, so that's nice. You don't need to initialize then the two-dimensional array, it seems. Okay, what's its x gonna be? It's gonna be I, and its y coordinate is gonna be at this j, actually, not yet. And solved. Is it solved? I would say it's yes or no. Depends on actually Sudoku that we are sending in on the I and j position, I and j position. If it's x, then it's false. It's not solved. Otherwise, it's true. It's solved. Let me see how I did it here. Okay. Oh, yeah, all right. This looks even better. So let's just do it like this. And of course, I didn't have a static class there, but doesn't matter. So what this does is we compare it. If it's not the x character, then we know it's a number. Otherwise, we just subtract 0 from the number. This means basically, if you have a character that is 9 and you subtract the 0 from it, you will get 9 as an integer. So this way we get the correct numbers into excuse me, into this number field. Okay, so this is for initializing these cells, and we can initialize them basically when we start just before we start solving. Initialize cells. Oh yeah, there is no sending Sudoku in. What does it say? Sudoku might be null here. Yeah, it might be, but it won't be. We will just ignore these warnings for now. Okay, so let's get some other methods in, like getRow, for example. GetRow is a nice method. Just so we wanna get every cell in a row by the index. So what we actually do here is we send the index of our row, and we get all the cells in that row, and we use yield return for this enumerable to do so. So yeah, and wanna make it static here. So since I copied this one here, let's do the other one on our own. Sudoku cell, let's get column by int index. Okay, Let's use the for loop and use by size. Okay, and we will return each cell that is on this row I in the column that we sent. Okay, as simple as that. Now getting the box is a bit complicated. You'll see why I'm using INumerable later on, but okay, so we need, for the box, we need both coordinates, and that's why I'm storing the coordinates into each Sudoku cell itself, because I will need these coordinates to get everything else from that cell, from the box that the cell is in. You'll see, it makes things way easier if you have X and Y in each Sudoku cell. And we need J index. And now let me just try to remind myself what it was. Okay, so what I'm doing here is I'm basically doing the math to get the Sudoku cells. So J box, I box, I index. So basically what this means is your I index can go from 0 to 8, right? If you divide that by 3, you will get numbers like 0, 1 or 2, which is actually identifier of the box, which box you are in. And the same goes here, like J index is a number between 0 and 8, and when you divide it by 3 you again get 0, 1, 2. Okay, and now in these loops, which look complicated but are really not that complicated, you start with an I, that is the box index you got, so 0, 1, 2, multiplied by size, which means we will get either 0, 3 or 6. Okay, and same goes here, 0, 3 or 6 is the first index you wanna get, and it goes up to the next one, the I box plus 1 or J box plus 1, which will be of course then 3 or 6 and 3 or 6 again, or 9 of course, because it's still less than, and there are still, index 8 is still a valid index for our Sudoku. Okay, and we enumerate through that box and we get something like this. I can show this in Paint, like, it's super easy actually. Okay, my Paint skills now are not the greatest, but okay. So if you are here, you will get, to get this box, so this whole box here, your index here is 0, 1, 2, 3, so I box is equal to 1, because divided by 3 it's 1. Okay, and your Y index is 0 actually. See, 0, 1, 2. So you are at this point 0 and 1 for these values, and these values iterate through like, they go like 0 times 3 actually, yeah, 0 times 3, and they give you 0, 2, 0 plus 1, that is 1 times 3 is here, 3. Okay, so they will look through this interval. Same goes here. We got this 1. Actually, I will mark it. You got this 1 by dividing 3 by the box size, and the next one is 6, which is here on the next box, right? And now this guy will search through this area here, and this way you got this box of each cell, and you will return each cell. So it's simple as that. Okay, so next thing. So how do we get all the possible solutions to each cell, since we are going to be brute forcing? Okay, private static. Let me see, did I use enumerable as well? Yeah. Okay, enumerable integer. And in Sudoku world they call this markers. So well, let's call it markers as well. And say, so we wanna get everything in the row, right? And we will send a cell here in this get markers method, so that we can, with that cell, only get everything around it, the row, the column, the box. So to get let's say row equals get row of cell dot x, for example, and then var column equals get column of cell dot y, and let's get the box equals get box of cell dot x cell dot y. So as you can see, this is why it's useful to have all the coordinates in, otherwise I would have to send them here, track them in some loops and stuff like that, which makes things a lot more complicated. Let's call this all markers. So let's combine these groups like row.concat. This is a method in LinkQ with which you can combine multiple enumerables, and you can chain it like any other link stuff. And we can use for each marker in all markers. And what do we wanna do now? What do we wanna yield return? We wanna return marker, right? But do we wanna we wanna check if the cell dot is solved? Then we wanna return the marker cell. So let me Sudoku cell to integer. Okay, integer that number. Okay, so we are getting actually the numbers. Yeah, sorry. Let me check if I did this. Okay. I did this differently here. Where solved, select number, concat to hash set. Where is this solved numbers coming from? Okay. Okay, let me check what I did this here and compare it to what I'm doing it now. So I was actually getting the same thing, where it's sold, so the same thing, selecting number, yes, selecting number, and sold numbers is all the possible number Okay. I was only returning the not possible numbers here. In this case, what I need to do is the opposite, actually. And I can do that by optimizing this code a bit here to look better. So for each marker, possible marker in actually no, I still need these. You still need to go through all the possible numbers to get the possible numbers that are not already there in this cell and everything. So therefore I will get this one, but I will shorten the code by saying where x is solved. Okay. And do I need anything else? And I will select from each of those the number, x dot number. And to make it prettier, I will just okay, like this. So this is the same as doing this, except I'm missing this to hash set. Hash sets is a nice collection. You can easily find if something belongs to that collection. So for example here, so we will get all the numbers, like if you are in here, you will get all the rows, columns and the box, you know, all the numbers that are sold. For example, number 1 is here, number 5 is here, number 6 is here, number 7 is here, and in this cell then you need to check from numbers 1 to 9 which of those are not these numbers that you found that are sold around you. And that's what I'm doing here. So as you can see, sold numbers contains possible number. So if the sold numbers does not contain some possible number, then that possible number is actually a possibility. Okay. Now let me remind myself. So we got the markers, cells, columns, box. We initialized. Okay. We will hide the solution. Solution to text we don't need. And solution to text fancy we already have. Okay, so only thing left is actually to solve the Sudoku. We prepared everything. Okay. So return solution to text fancy. Okay, let's create private bool solve next. Let's build the skeleton for it, not the actual method. And if solve next of 0 is true, then we will return solution to text fancy, otherwise we will return impossible, something like that. Impossible. Yeah. Okay, let's make it look cooler. And this needs, since we are turning the string array, we'll just return it this way. Then you see, we need to return some sort of a string array. So we'll just return this instead of the solution. Okay, so how do we solve the how do we solve it now? Private static, let's say it's read only list of Sudoku cells to solve. Which cells are left to solve? Okay, where is the initial cells? Okay, so let's clear that here. So every time we call this, even though it's a class, it's a static class, let's call it here so we can do the reclear every time. And okay, let's get some help here. See what I did in. Okay, so there must be also a way where I think in initialize cells, yeah, this is important part. So we need to know where, when, how many cells are there still to be solved. So if this cell during initialization was not solved, then we add it to cells to solve. Okay, now that we have that, if let's say index equals okay, let me see what I was doing here. Okay, so what will this index mean? This index will be actually like a number left to solve. So if you reach the number of cells to solve without returning false somewhere, you are actually on the right path. You actually solved the Sudoku. There's nothing left and everything fits. Okay, so let's check this code here. So we're getting the cell. And okay, index, why is it called index? Because we are going through the cells to solve. So our cell equals cells to solve of index. Okay, and now we wanna get its markers, its possibilities. Means cells dot get markers. Okay, actually get markers of the cell, right? And this is enumerable for some reason, of course, because it's way easier to do it like this, but honestly this should be a list, so let's change that. Let's change this to a list. Okay, so instead of yield returning, we'll do new list integer, which is called markers. And we will return markers. Why this? Because this is enumerable. Everything here is enumerable, which means as long while you're doing this, while the code is running, parts of enumeration might not get called, and what will happen is you may change the list of these markers while you are working with it, and it will affect the whole code that was running before, and you will get that error. Enumeration may not be changed during the collection must not be changed during the enumeration error. So to avoid that, instead of like calling here to list, I will just turn this method into returning list, because it doesn't have to return INumerable. I use INumerable here, here, and here because you see it's easier to work with those like that. Okay, var item in collection. Okay, yeah. So what if our markers dot count equals 0? It means markers, as we said, are possible numbers. If there are no possible numbers, well, we just return false. And now let's continue here. Now let's check each marker. And before that, sorry, something. We can make this cell that we are working with, we will mark it as sold, just so it doesn't get into these enumerations like get row, get column, get box. They all are looking for the sold cells as well, so we don't want this one to get returned as an option. Actually, yeah, we don't want. I don't think this line matters. I will just remove it and see it later. Actually, let's say it matters, because why? In the end, you want all the cells to be sold, because in this solution to text fancy we are only going to get the sold. Maybe not. I don't know. I don't know. Like, honestly, I don't know why I put it like this. We will see. Anyways, now we assume the number that we are trying to solve. Here is this one of these possibilities, one of these possible markers, and then we see what happens if for the next one on the list. It's as simple as that. And this is the recursion that we are calling. So the next on the list, if it's valid, in the next of the list, if it's valid, if the marker count is not 0, if the next, if all of them are valid, then we are good. And of course, if you reach this point, then it's, you know, if you went through all the markers, all the possibilities, and still it's not solvable, it means you messed up somewhere along the way. Okay, I think we are pretty much good already. Okay, and I prepared a sample for us, which should work fine if we did everything right. Okay, I would just say. Okay, my only idea what could be null here is these cells that we did not initialize. Okay, and let's put size. Okay, that should be it. Let's see what else it's never assigned to. What do you mean? It's assigned here. Nah, never mind. Again. Okay, cells are here. Okay, our Sudoku is null. So let's see what happens here. Oh yeah, we did not write any code for input. We just need a for loop. Let's put it by size, and let's say console.readline Sudoku of y equals console.readline, and that should be it. Let's see. And let's take this one. Solution. There we go. I could try to connect my phone and see. Actually, you know what? Let's Google some Sudoku. Sudoku online. Oh, wait, where is it? Expert. Okay. Expert. Okay. So let's try out our program in action. Let's see. Okay, first row is empty. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then a number 6, 2 spaces, 3, 4, 1 space, 1, 1, 2. Yep. 3, 4. And here is the solution. It takes some time, like a second, to solve. It's still a brute force, but works pretty well. So let's see. 2, 4, 5. 197 actually. Two, 4, 5, 1, 9, 7, 8, 6, 3, 6, 7, 8, 2, 1, 9, 5, 9, 3. Where am I? 5, 6, 8, right? 2, 2, 4, 7, 3, 5, 4, 9, 2, 6, 7, 8, 1, 7, 6, 2. 3, 9, 8, 1, 9, 4 7 oh sorry 3 5 2 6 4 9 7 6 8 5 3 1 2 1 2 6 5 3 7 3 2 1 9 and that's it. Time 3 minutes. Not bad, not bad. I'm guessing all record holders would be even faster than my copy pasting, but there it is. Solution to Sudoku. Super simple when you look at it. Let's see what we did. Okay, what if this is null? Let's just give it a value. Okay. New expression can be simplified. Okay, cool. Okay, so we just input the Sudoku, then we initialize the cells, then we solve the next one, then we solution to text fancy. Okay, let me line this up here like this. Nice. And here we check if there's no possibilities left for the cell that we are currently looping through, then it's false. Yeah, I don't think this line is necessary. Let me check. Let me think about it. If markers.count, markers never change, right? Markers should never change. Let me comment that out and see if this will still work. I think it does. I'm pretty sure it does work, but not sure completely. Let's print screen this, open the notepad, Paint, and let's oh my god, come on. Print screen. So yeah, I'm pretty sure it works. Yeah, I don't know why I had this line here. It was my previous attempts probably. And about this cell sold and cell not sold, let's try that out. I don't think that's necessary either. Okay, so let me copy, paste my... Okay, now you can see it doesn't work. You can see once. Okay, so this is the solution. Okay, so let's go over it one more time. So basically we just input the Sudoku. We have the Sudoku cell matrix here. It's not an array of array, but actually matrix. So let's get solution last. So markers are the possibilities that can go into a single cell. We get all the rows, columns, boxes, and everything around it, and then we filter it by where it's only the sold ones. We select the number of the sold ones, and we put that into a fast collection, like a hash set. Fast collection, I mean you can check if it's in this collection fast. So by doing this possible number from 1 to 9 and just checking through this collection, this operation is super fast. So that is basically it. and we just return the list of possible numbers that can go into a certain cell at a certain point in time. This is just for getting a row. As I said, you just fix the row and get all the columns. Similarly, the column, you just fix the column and get all the row cells of that column. Box is a bit more complicated, but as I said, you know, I try to explain it. So you just need to get all the elements in a box for this I and j coordinate, or x and y. Initializing is basically just initializing everything here. And what's this? Sudoku may be null here. The reference of a possibly null reference. Okay, can we just do this? Like, okay. Like this. Why not? Sudoku may be null here. Why? It's never null. Let me check again. This guy still works. Okay. Sudoku may be null here. The reference is a possible null reference. Why am I ever putting it as a nullable? I think there was some error Visual Studio recommended to me. Anyways, no errors, no warnings, no messages. Works fine. And I just wanna actually, like with Alt, let's do it like this. Okay, I won't go into detail how I made this, but you can try it yourself. It's just a custom display. You know, when the Sudoku is solved, you see this cool display here. You could just go over every get row, select the number, and just print it out. But this is some cool way of doing it. Okay, so this is basically the algorithm, super simple. If there's nothing left to solve, everything is solved, return true. Finally, otherwise check take the next cell that needs to be solved, get all the possibilities that can go into that cell, mark it as solved. Currently, go through all its possibilities, try to solve with a certain possibility, and then just recurse that. If that doesn't work, nothing, it will return false somewhere doing its path. Otherwise, when we get to the true one, then this marker is fine, then we return true. So yeah, that's basically it. Alright, thank you guys for watching, and goodbye.